So far, we've been talking about programs that only contain single pieces of data. You might have multiple variables, but each variable only contains one thing. It might be a number, might be a string, might be a Boolean value like true or false, but regardless, it only contains that one thing. Now, that's okay for simple programs, but as your programs get more complex and interesting, you're going to need to be able to have the capability of associating multiple pieces of data together with each other. You want to hold them together. Now, Python has many different ways of doing this, but the most common is to use a sequence type. There are many different sequence types in Python, but today we're going to talk about the most common one, lists. So with that, let's get started on our lecture on lists. So I want to talk about lists. Okay, what is a list? Well, let's make a list, all right? I've got a list of things that I need to do. I need to teach class. I need to get some sleep. Yeah, like that's going to actually happen, okay? I need to skip my meetings. All 6 of them. Don't want to go. All right. So I have a list here, and I think you'll agree this is a list. This is my to-do list, perhaps, for today, of things that I would like to get done and probably won't. Okay, so how does that relate to lists in Python? Well, pretty much this is the general concept. I have a bunch of things that I want to sequence together, and in fact, I put them in an order here. I might actually number them if I wanted to. You know, this is number 0, this is number 1, and this is number 2 on my list of priorities. Okay. In Python, I would make a list. I don't write it out like that. I write it in square brackets. So the square brackets say it's a list. And this right here is an empty list. Okay, there's nothing in it. So I have the square brackets around it. I could create a list of numbers. 1, 2, 3. I could create a list of strings. And don't forget the quotes around here. Okay, so all of these things are lists, and they associate a bunch of data, 0 or more pieces actually of data together. So I've got my empty list, I've got my list with 3 numbers, I've got a list with 2 strings in it. Now, usually I will be assigning these to variables, so I might have something like position equals the list 4, 9. And implicitly, this here maybe is my x coordinate and this is my y coordinate, so I know that my position is at x equals 4 and y equals 9. Okay, so out of context, without me writing this, you don't necessarily know what these things are. You know, I've got this empty list. What does that mean? I've got nothing to do today. Yeah, that would be nice. I'll take that. This list of numbers here, who knows what this means? Maybe these are the times at which my next 3 meetings that I fully intend to skip are going to occur at. Maybe these strings here are greetings that I'm going to say to you, depending on whether I'm just meeting you or I'm about to leave, okay? Again, the position might be XY, the position might be some other coordinate system, okay? So a list is a way of associating data, but it doesn't give you a way of saying exactly what the pieces are. That's something that you're going to need to keep track of, okay? But the basic idea is here, a list, square brackets, 0 more things. Doesn't have to be 0, 1, 3, 2, whatever that I've got here. It could be 0, 5, 1,000, 100, whatever, okay? But I'm just going to keep a bunch of data together, and this is going to allow me to have one variable here, position, that keeps track of the x and y position of something, rather than having to have 2 variables, one for the x value and one for the y value. Okay? So let's look at what this actually means in a program. All right, let's actually have some fun with lists. So what can I do with lists? Well, before I can do anything, I need to be able to create a list. Let's create an empty list. All right, maybe this is not so useful, but I just want to show you that you can have a list with no elements. When I print it out, it uses this bracket form, so 2 brackets with nothing inside them, empty list. It's not all that useful. Maybe sometimes I might want that, but usually I'm not going to. Let's make a list with a bunch of numbers in it and print that. You can see that I now have a list over here that has a bunch of numbers in it. 1, 3, 4, minus 7, 62, 43. Lists are not limited to numbers. I can have other things in my list as well. Let's put my grocery list up here. There we go. Print L2. Now I have a list with strings in it. Okay, so there's no reason why it has to be numbers. It could be strings. I can have Boolean values. I can even have other lists in my list. Okay, so what did I just do here? I created a list that has lists inside it. Now here's a question for you. How many elements are actually in this list? Let me give you a second to think about that. All right, there are a couple of possible answers here. I can count 3, 4, ABC, so I can get 5. That's actually not the correct answer. The correct answer is 3. Okay, there's this first list right here, then there's this second list right here, and then there is this empty list right here. Okay, so I want to point out the characteristics of a list when you create it in this fashion. I have to have an open bracket and a closed bracket. Inside the brackets, I can have any number of elements separated by commas. And each element can pretty much be anything that Python will allow you to put into a variable, any kind of value. So it could be numbers, could be strings, could be other lists, could be any other type that we're going to talk about. Okay, so that's nice. I've been able to create a list. I can print a list out to the screen, but it's not really all that useful. To be most useful, I need to actually be able to access these things. Now, before I start accessing, I want to point out the following, that you can actually call the len function. And let me do len L3, just to prove to you that the answer is, in fact, that this last list has a length of 3. Okay, so the empty list has a length of 0, this list here has a length of 6, this last list here has a length of 3. Now, at this point, you might be saying, hey, I've seen len before. Yes, you have. You saw len when we talked about strings. And if you go over into the documentation, the Code Sculptor documentation, I want to point out that both lists and strings are sequences, and so a lot of the operations that we talked about for strings are also valid for lists. Okay, so you can go over here and take a look at that, and if you can remember anything that we talked about with strings, they're still going to be valid here. Okay, so I can print out the length. I can also access individual elements. Right, I can access the first element, I can access the last element, and if you remember from the lecture on strings, as a shortcut to get to the last element, I can use -1. If I do this, you'll see I'm going to print 1, which was the first element, 43, which was the last element. Okay, I can also access elements in the middle of things. Let's look at that first element of L3. If I print out that, now remember first actually is the second because computer scientists are all crazy and we start with 0. Right, so if I run this, I get the list ABC, right, the entire list, because that entire list is the element in the 1 position here of this list of lists. Okay, I can also do slicing just like I could with strings. Let's say I decide I no longer want milk or butter. I can, well, let's actually assign it to a new list. I can do this, print L4. Okay, what happens? I get a new list with just eggs and bread. Now recall in Python, when I talk about ranges of things, I have this 1:3 syntax. That means starting at element 1 up to but not including element 3. So I get element 1, element 1, and element 2, eggs and bread. Okay. Now lists also have a capability that strings do not, and we're going to talk about this more as we go along, but I can actually change elements of lists. So if I decide in my grocery list I no longer want milk, instead I want cheese, I can assign to the 0th element of the list a new thing. Okay, and I run this. Now you'll notice I have cheese, egg, bread, and butter instead of milk, eggs, bread, and butter. Okay, all right. Now you also notice that all of my lists here, I've always had the same kind of thing as every element. You can have as many elements as you want as a list, but good programmers keep their lists homogeneous, where if they have a string in the list, all the elements are strings. If they have a number in a list, all the elements are numbers. If there's a list as an element, then all the elements are lists. And trust me, this makes your programming life a lot easier, so I highly recommend that you try to follow that discipline as well. In many ways, this was probably a pretty boring lecture, right? We didn't actually see any useful or interesting example programs. Instead, we just looked at the mechanics of lists. Okay, well, we did that because you need to get the basics down, and pretty much all the other lectures this week are going to use lists while they teach other concepts. So you're going to see plenty of examples with lists, so don't worry too much about that. Okay, so if you only take one thing away from this lecture, it should be, well, that I'm going to skip the rest of mostly with Joe anyway, right? No. Okay. You should take away the fact that lists are a collection of objects. They allow us to keep data that belongs together without having to have a bunch of variables to hold it. Okay? We're going to see how that works in action. We're going to see how you can do that in programs as we go on. And you also might have noticed we've snuck lists in here and there throughout the previous lectures of the class. Every once in a while they found their way into a program. So now you know what's going on, and you're about to know more.